Hello everyone, this is Darshan Patel, and today we are going to talk about Wi-Fi 6E. So let's begin. As we know that actual evolution started with Wi-Fi from 2009-2010 when iPhone and later on iPads were introduced. Before that, it was more about devices trying to use it and connect their PC or barcode scanner and areas, maybe manufacturing, maybe retail and enterprise, but it was limited. Slowly and gradually from 2011 onwards, it has picked it all the way and it has become the necessity. It's not only good to have, but very important requirement for connectivity. As of today, even in the hybrid world, we need wireless connectivity. More and more IoT devices have started coming up since last 2 to 3 years, and we have designed a specific radio for it, which works along with BLE, and it's called IoT radio or BLE radio. And what does it help? On the top of that, we have covered through our DNA spaces videos. But the evolution has continued to drive because of we got the best of the world, but the requirements keep on increasing. It requires a customer need high quality videos, and more bandwidth requirements are driving for the new evolution of Wi-Fi. So said that, okay, 802.11ax, it's high efficient, it's great, but is it really? What are the limitations that we have even with 802.11ax? So we got 802.11ax, but we need a new spectrum to drive the bandwidth requirement, new IoT adoption, more extended outdoor range, and the performance, which is the most important thing. So let's look into it. What are the limitations that we had it with 2.4 and 5 gigahertz as of today, and why Wi-Fi 6E is going to drive it? So what current challenges do we have? We have way too many devices and shared spectrum. With 2.4 gigahertz, it's overkill already. We have 3 non-overlapping channels on, as you remember, having issues we started with, even though we have improved 2.4 as well with our BSS or OBSS coloring. But is it really helpful when you have limited number of non-overlapping channels? And even with the 5 gigahertz, we say that we have 25 non-overlapping channels. But let's talk about it. There are issues that we have seen with radar detection and the DFS channels. Some or more of the customers do shut it down. That leads us to only 9 non-overlapping channels. And think about it. The next thing is about channel width. We moved from 20 megahertz and showed that, okay, 160 megahertz channel width is achievable even in 5 gigahertz. But is it practically useful? Can any customer actually use in the real world? And any customer is even able to use 80 megahertz. How many are there? And what areas? There are very limited environments that is possible. Yes, 40 megahertz, we have seen it, our customers using it, but that is also limited. So that channel congestion, DFS, and on the top of that, old legacy devices, considering I still remember even a year before, we continue to support 802.11b data rate of as a minimum requirement because customer had barcode scanners that they cannot move. And that's where we require a clean picture moving forward. And how is it possible? That is possible with our new Wi-Fi 6E spectrum that has 1200 megahertz clean. Start with very clean format that we do not have any backward compatible. We do not want to have the legacy security requirements with WPA2, WPA TKIP, and old barcode scanners that we talked about it, because it degrades the entire performance of the Wi-Fi, and because it's a shared spectrum, and it is a half duplex. Even though we achieved so much with 802.11ax with high efficiency, and good thing is, all those great things, for example, 1024 QAM, more number of bits that more data can be transferred, BSS coloring, it is even going to get better with OB overlapping basic service set. And we will talk about that later. But that's where it is even getting better. OFDMA, why to waste the airtime? Instead of that, share it with other users. And it helps with the next thing, downlink and uplink multi-user MIMO, moving from single user MIMO. And the most important, as IoT devices, mobile devices, tablets, battery is the most important thing. And transmit wake-up time help us to preserve it. So we are also taking all that great things with AX and moving into the new entire spectrum with better, more number of non-overlapping channels. And we will talk about how utilizing the channel width in 6E is actually beneficial rather than reduce SNR if we continue to increase our channel width from 20 to 40 to 80 to 160. And what's going to be new normal? So let's take a pause over here and try to analyze the number of non-overlapping channels that we have. With 2.4, only 3 as we know. With 5, 25 non-overlapping channels. And in most of the scenarios, certain enterprise, public sector universities, they have deployed 40 megahertz as per the environment needed. The other sectors as well, they can use it. But most of, for high density, we are still going with 20 megahertz. Now let's take a look into the number of non-overlapping channels that we have over here in 6 gigahertz. 59, yes. And 29 40 megahertz and 14 80 megahertz channels. So the new normal will become 80 megahertz channel width. Just think about the speed. Like in the real world, we will be able to see it. And I won't be surprised to see more than a gig on a Wi-Fi for the first time. Yes, that's what we are talking about. And that's what I'm expecting from Cisco Wi-Fi 6 EAP when we will introduce. Nothing less than that. Otherwise, it's of no use, right? Why to move from AX to AXE, right? That's what I call it, 6E. So access classes and the power distribution. In 6E, it is going to be distributed into 3 different classes. Standard power, which is utilized for most of the times for outdoor. And it is going to be 36 dBm EIRP. Indoor, or which we call it LPI or low power indoor, which will have 5 dBm per megahertz. And we will talk about power spectral density and how that power spectral density helps us in order to have that more channel width, and how our client is always going to be 6 dB less. So our clients are always going to have 6 dB less than AP's max EIRP. Very low power devices is under evaluation. But what I expect is most of the times Cisco, Aruba, Mist, and others are going to introduce more about indoor AP. But while introducing and trying to be the first in the game, is it important to have the best one first? Or is it important to have just the minimum requirement, like 2x2 radio? Depends. What's their strategy, what the customers are looking for. But it's always best to see the 6E product, right? To see what else we can do. I'm so excited to see that 1 gigabits per second on Wi-Fi and see how more and more application which are bandwidth hungry we can provide and use it on Wi-Fi. So we talked about power spectral density of 5 dBm per megahertz. So what does it do? How does it help? So if we convert 5 dBm into milliwatt and try to multiply with 20 megahertz, it gives us with 18 dBm. And if we move to 40 megahertz, it increases to 21 dBm. So the next question will be, and I was confused, like how? How is it going to work? Because we thought that if we continue to increase our channel width, it reduces our SNR by 3 dB. Everything from 20 to 40, it reduces by 3 dB. From 40 to 80, it reduces it 3 dB. But that's true. That's true for 5 dBm. But it's not true when we talk about 6E. It actually increases and beneficial. So let's talk about how does it work, right? And this is a clear picture that we understand that, hey, what do we mean by increase and what do we mean by decrease? So let's take a look into our 5 gigahertz. As we can see, 20 megahertz channel, and it reduces 3 dB SNR. So in fact, it reduces the signal strength by 3 dB. So the performance was going to continue to degrade as we continue to increase the channel width. And that offsets that. So what do we do with the power spectral density? So that's how it is going to be useful with Wi-Fi 6E, that it is for 5 dBm per megahertz. That helps us to increase EIRP, and that helps us to offset that signal to noise ratio loss. So as we can see over here, the 5 gigahertz in uniband, it reduces as we increase the channel width, and it increases 3 dB with the channel width. So it is a good thing and the best thing for the better performance to use higher channel width in 6E. That's great, isn't it? With that, we will conclude for this video and stay tuned to talk about what is Wi-Fi 6E security and how is it going to be better. How we have removed WPA and WPA2, right? And why WPA3 is necessary to begin from the clean point of view. How hash2 element is going to be used with .1x SAE. And what does the OWE or open authentication is going to work. We have removed PSK as well and moving forward in 6C standard. So let's say, what does the PSK removal means? Thank you.